As it turns out, you can calculate the molar mass of a gas if you can experimentally determine the density of the gas. It's a lot easier to experimentally determine the density of a gas because you just have to weigh the gas over a given volume than it is to experimentally determine the molar mass. So let's take a look at this problem and see how we can, given some information about a gas, calculate the molar mass of that gas. The oil produced from eucalyptus leaves contains the volatile organic compound eucalyptol. Volatile means evaporates easily. At 190 degrees Celsius and 60 torr, a sample of eucalyptal vapor had a density of 0.320 grams per liter. Calculate the molar mass of eucalyptol. Okay, so what do we have given here? We have a gas at a given temperature and a given pressure. And we also have the density of that gas. The question is, how can we calculate the molar mass of the gas? Well, you need to remember that there's a relationship between the density of a gas and the ideal gas law. And that is the density of a gas is equal to the pressure of the gas times the molar mass of that gas divided by R, the gas constant, and T, the temperature. Okay, so we have an equation relating the density to the ideal gas law, which includes the molar mass of the gas. So all we need to do here is rearrange this equation, solve for molar mass, plug in the values that are given for temperature, pressure, and density, use the correct R value that has the pressure unit expressed in torr, and we can very easily calculate the molar mass of this gas. Let's get to it. First of all, I'll rewrite the equation. The molar mass of the gas is going to be equal to the density of the gas times R, the gas constant, times T, the temperature, divided by P, the pressure. Okay, let's get ourselves some room to work here. All right, so we have our equation. What can we plug into our equation? Well, the temperature is 190, but we have to express that in terms of Kelvin, of course. The torr we will leave as torr. We'll just find the right gas constant for torr that has the torr unit. And the gas constant that has the torr unit is 62.36 liter torr mole Kelvin. Okay, so that's going to go in for R. The pressure is going to be 60 torr. T is going to be 190 degrees plus 273 degrees. All right, so I think we have, oh, and the density, of course, is 0.0320 grams per liter. So let's work that out. Let's write it and see what we can get. Okay, so the molar mass of the gas is going to equal the density of the gas times R times T divided by P. That's going to be 0.320 grams per liter times 62.364 liter torr mole Kelvin times 190 degrees Celsius plus 273 Kelvin is equal to, let's see, 190 plus 273. It's going to be Kelvin. And do the math in your head. I can't do it that fast. Divided by 60 torr. All right, let's see here. The torr unit's going to cancel. Here we go. The Kelvin's going to cancel here. The torr unit's going to cancel here. The liter unit's going to cancel there. That's going to leave us in units of grams per mole, which is a molar mass unit. And when you do the math, it comes out to 154 grams per mole is the molar mass of the eucalyptal vapor. Good job.